It's Wednesday, May 20th, and today on the Data Show, we are commemorating the 10th anniversary of BigQuery. Here we go. Hello and welcome to the Data Show. My name is Yufeng Guo, a developer advocate at Google Cloud, and
I'm here, Felipe Hoffa, developer advocate at Google Cloud too.
we are so excited today to be
we have a really special show.
very special show. Many amazing guests and messages from all around the world.
Yufeng,
Yes, what's up, Felipe?
Yufeng, I have a special guest.
Oh, a special guest.
Yes. I mean, we have a lot of special guests, but we have a very special one now.
Extra special.
Yes, I know we've rehearsed and we practiced all of this, but
Yeah, we rehearsed this whole opening. Yeah,
but can we have a special surprise for everyone?
yeah. Let's do it. I think we can fit that in.
Yeah, it's Google employee number 8.
Employee number 8. Is it? You
Yes.
got Urs to join us?
Yes,
All right.
the creator of Google's infrastructure is here to say happy birthday to BigQuery.
Oh my goodness, that's amazing. Okay, let's do it. Oh wow, you really did it. Hi, Urs.
Hi everyone. Let me tell you, back in the olden days, we didn't have BigQuery. In fact, we walked to work barefoot through the snow, uphill both ways. And, to count things, we didn't have a fancy data warehouse. We had an abacus, made from bare metal. And that was enough. But then, pretty quickly, we had MapReduce, and that was sort of nice, but it was just a lot of work to get stuff done. And so, someone smart said, there's got to be a better way. And that's really how Dremel started. And Dremel was our internal version of BigQuery, type SQL, columnar data store, like insanely fast. And before we knew it, we had like 10,000 internal users of Dremel. And that's when we knew we really had something that had sort of the potential to change the world. And then, 10 years ago, we launched BigQuery, and since then we had, what did I read? Like our first user running 100 trillion row query on it. So it's really amazing how far it's come. And I did want to say congratulations to the whole team. This was 10 years of a lot of work. It started actually in a much more basic state than where it is today. We didn't have visualization, we didn't have visualization, we didn't have GIS, we didn't have ML built in, right? It was really just sort of barely a way to summarize data. So huge congratulations to both the Dremel team. I think we have some on the show afterwards, and to the BigQuery team, of course. And then also thank you to all our users for the feedback, and that really helps us make a great product. And so with that, I think we have a video with some other people who are congratulating us. So thanks again. Congratulations.
Thanks for stopping by.
Thanks,
You're
Urs.
welcome.
Hi, it's Vince Cerf. Happy 10th birthday, BigQuery, and thanks for helping make MLab data so useful.
Happy birthday, BigQuery.
Happy birthday, BigQuery.
I can't believe you're 10 years old now.
You and my son both turned 10 this year.
You've done such amazing things for a 10-year-old.
Thank you very much for helping us to make maps like this. Are a billion times bigger than this.
お誕生日おめでとう。
I heard that today is a very, very special day, and for that I want to say
Happy birthday, BigQuery.
Thank you for being so nice friend for me and my clients.
I remember when you just got started.
You ran on 100 cores and had 50 terabytes of total storage.
It was way before standard SQL, integration with Data Studio, all the statistics functions you have. You've really grown into a first-class data warehouse.
And today, you're making maps, training models, and even going in loops. I can't wait to see what the next 10 years brings.
You're just getting more powerful every year.
Here's looking to the incredible things you'll make possible in the next 10 years.
Happy birthday, BigQuery.
Here is a big beauty hug for you.
Happy birthday, BigQuery. Happy birthday, BigQuery.
Happy birthday to the most famous product of Google Cloud. I'm very proud of BigQuery and have a ton of great memories with the team.
You and I see our world in the same way.
It's all data. It's been a lot of fun to look back on everything that you've accomplished in your first 10 years.
But I do feel really privileged to have worked with one of the most talented teams in the industry and one of the best products in the industry. So congratulations on 10 years and keep up the amazing work.
We at AirAsia are very grateful for your assistance.
I really appreciate all you do for helping me analyze and research open source projects.
Thank you to everyone who is involved in this amazing job.
Happy birthday, Google BigQuery.
Have a blast.
Yes.
All right. And we're back. Felipe?
Yeah, that was a good start.
Yeah.
And I mean, Urs, the creator of Google Infrastructure, was here to meet us. And Jordan, did you know that he was going to come?
No, you mentioned that there was a special guest, and I did not guess Urs.
Yes, but let me introduce Jordan to everyone. Jordan is one of the founder engineers of BigQuery. Like more than 10 years ago, he started this crazy project with an amazing team, and he has throughout the years became the director of the engineering for BigQuery, and now he's the director of PMs. So what a great way to start this video and celebrate our 10 years. Hi, Jordan.
Hi, Felipe. Thanks, and this is so exciting. I first wanted to just say thanks to all the awesome team that we've had over the years, the engineers, the SREs, product managers, support folks, tech writers, DevRel. It's been really an honor to be part of that team, and then also to thank the customers who've pushed us to be better, to do better, and to make BigQuery bigger and faster all the time. I just want to say when we started BigQuery, we were thinking big. Google's motto is organizing the world's information and making it universally accessible and useful, and we thought, well, what if we could do that with databases? A lot of data is locked up in databases, but what if we could make it so that all the world's structured data looks like one giant database, and you can mix and match, and you can query it all together, and it just works. Serverless wasn't a term, but that's we wanted it to be serverless, and I think we've done a reasonable job of that so far, or at least we've started on the path. We have customers that are taking lots of databases and merging those all into BigQuery, and they take their data lake and they throw that into BigQuery. They're joining their own data against our public COVID data sets to be able to map and predict the spread and how that's going to impact their business. So it's been a really exciting time. We've scaled from I think I think that was Siddharth mentioned that we had 100 cores. Now we're not allowed to tell you how many cores it has, but it's many orders of magnitude higher than that. Many exabytes of data, and we were able to build on some incredible infrastructure that we had at Google. Some that Urs built himself by wiring together the components, but then the rest was history.
Yeah, amazing.
No, it's really crazy how things happen. You were going to say.
No, over to you. I think you had some questions.
I was waiting for you, Feng, if you had any questions.
No, I don't have any direct questions for this. Yeah, go ahead.
Yeah, no, I was just thinking how crazy it must have been to take this internal project that was working that and propose to go to Earth and ask him, should we make it a cloud product? Like, how was that process?
One of the things was Google was very distributed at the time and very bottom up, and we just sort of did it. It was there was a site director who was supportive of kind of building some cloud products, and and it was sort of like you can start it, and if they don't like it, they'll shut you down. But you can kind of you were empowered to do whatever you want, and I think we've gotten way beyond the point where we have to worry about somebody getting us shut down. I think now we're one of the it's one of the key things in Google Cloud. But for a long time, we were able to just sort of operate under the radar and build the thing that we thought would work well for our customers.
Awesome.
Yeah.
So
I'm.
No,
please.
go ahead, Felipe. The intercoastal delay.
Yes, I'm in San Francisco. Yufeng is in New York, and Yufeng has all of the controls of what happened today here. No, I'm just so excited. I don't know where to go first because we have new features to talk about. We can talk about the history of the project. We can talk about the amazing community that has built around us.
Maybe the community part, just because I think that that's one of the things that has been really special, and I noticed some of the people from the community already showing up in the YouTube chat. But I think one of the things that we did right early on was we really engaged with the Stack Overflow community and kind of nurtured those, and people felt like they could go and they could get an answer, in minutes, if not faster. And sometimes, especially in the early days, if somebody had a problem, we would be able to be like, oh, well, that's a bug, and we would fix it that afternoon. Like we could just turn that around, immediately. And it was sort of an exciting, fast-paced time that we were able to move quickly. And I think also the fact that we had that community, they were able to give us the feedback. If you keep seeing the same question on Stack Overflow, you're like, well, maybe we should just make this easier to do, or make this easier. And I think some of the BigQuery's ease of use type features were things that kind of were we were really helped by our community from the early days.
Oh yeah, if I could highlight some people, we have Michael, which has been a monster of answering Stack Overflow questions, and we have right now Martin Kodok in the chat. He was one of the first users of BigQuery that I met because he was replying to so many questions, and he's been such a big part of this since the beginning.
Yeah, those are great. I remember competing with them for the the #1 Stack Overflow answer, and now they're way beyond me. Mikhail was they were both machines at Stack Overflow. I'm not sure how they get anything else done.
Yes, I have a trivia question ready for you, and Yufeng will be able to answer it with a query.
Yes.
Let's talk about the last quarter of BigQuery and Stack Overflow until March, 3 months. How many page views did the BigQuery tag get in 1 quarter in Stack Overflow?
How many page views?
Yes.
5,000, it's my guess.
5,000 page views for BigQuery questions in Stack Overflow?
And you got to dream bigger. So we've got this query here, a nested select statement, and we got our tag Google BigQuery. So I already ran it before, but you can see that it will process 1 gig and run. I'll run it again because, hey, we're doing it live, right? And let's see what we get.
And you can see that we're comparing 2 different snapshots of. Oh, yeah. We have the answer.
And we have the answer. Sorry,
yes,
I'll go back.
Than me.
Yeah, we're
it's
comparing,
okay.
Comparing the questions from March 2020 to December 2019. And yeah.
Exactly. If we have snapshots, we can get the number of views, and the number is?
It looks like it's just a hair over 1 million. So
yeah.
So I guess I was a little bit wrong. I think I'm anchoring on BigQuery of like 2014.
Yeah.
Maybe that's when you stopped answering BigQuery questions on Stack Overflow.
Yeah.
But
I answered one yesterday.
Oh, good. Oh, yes, I saw it.
From Michael Manucheri, who was the first DevRel for BigQuery. He came in with a question and one that I could actually answer. So that was kind of a blast from the past.
Nice.
Me answering and him asking.
Yeah. And since we are celebrating 10 years, yes, I have to say, Michael Manucheri was the one that found me and made me a DA 7 years ago.
Wow.
So, yeah, I just love that. Okay.
That's
why
yeah.
I'm here. And yes, he had a question yesterday. Jordan answered it. And what's very interesting about that question is that later here we have one of the software engineers that made that feature possible. So we'll wait for that part with her.
Yes.
So yes.
Okay.
What questions do you have for Jordan, Yufeng?
I mean, it's still incredible that just the fact that you've been with the project so long, 10 years working on this and kind of dedicating your time and energy toward this, and the transition you have taken, the path, right, from writing the code that built this product to then kind of scaling out your influence and leadership to now become the PM director for BigQuery, which is now, even though it's one product, has many teams and lots of engineers working on it. And so you've kind of been able to grow up with BigQuery, so to speak.
I think you're maybe giving me a little too much credit. It felt a little bit like I've just sort of been like hanging on for dear life as like this rocket ship is going off, and I've been very fortunate to be in the right place at the right time in a lot of ways, and it's just it has been an honor. It's been it's different every day. It keeps changing. Every new milestone, every new order of magnitude that we pass, it gets different, and in some ways more fun, in some ways harder. But there's more. There's a lot more people to help nowadays, and which is really great.
Oh, speaking about big numbers and features to announce, I have 2 features to announce today. But let's talk about the first one now. Hourly partitions.
Yeah, so those are launching today. You've been able to do partitions on days and range partitions for a long time. A lot of people wanted, their data is coming in so fast that they really need to be able to partition more granularly. So yeah, hourly partitioned are just launched today.
Yeah, it's crazy that people need hourly partitions. That means there are people that are receiving like hundreds of gigabytes or more per hour just to need that kind of partitioning. So
that is
amazing.
like it's not something that we never necessarily would have like thought to build into the product, initially, certainly, and even in recent years it probably wasn't necessarily a relevant thing, but now as just more and more data is being produced in the world in all sorts of applications, that's a I mean, do you think we'll someday have minute partitions?
I was talking to a customer yesterday who's streaming 10 gigabytes per second, and so when you stream that fast, you can put it. An hour is still a lot of data. I think that's still a terabyte of data. I don't know. I'm not very good at mental math.
It's just a bucket load of data.
Yes.
Yeah.
Jordan, we have many more guests coming now. I would love to have you back at the end of the show so we can announce the second feature that we want to announce today.
Sounds good.
Yes. Can you give us, who's coming next, in case you want to give us a preview?
Do I know who's coming next?
Yes, some paper writers.
Oh, yes. I do, but I don't know exactly which ones we have on. Oh, it's Jingjing and Moshe. The Jingjing and Moshe. Yes, some of the early founders of Dremel, and they're the ones that know how everything works. So they'll be great.
That's so funny that we have enough people to have whatchamacallit, so many paper writers we can't even keep track of which ones we're talking about.
Well, thank you.
All right, and
Thank
so
you.
we'll leave you. Yeah, we'll leave you with a little video from some of the team members talking a little bit about BigQuery while we get Jingjing and Moshe on. All right.
Lots of Google Cloud products have big code names, like Big Store for storage and Big Cluster for compute, that all fell by the wayside when those products launched. When it came time to launch BigQuery, we considered renaming it, but in the end, we decided that there was no better way to describe the unique power of a product than big and query. So the name stuck, and the rest is history.
I was one of the founding engineers on BigQuery 10 years ago now. I helped build a lot of the service infrastructure, the metadata systems, and the managed storage.
I started as a software engineer where I worked on a wide variety of projects, from our API and metadata design to our storage encryption layer to the initial version of the BigQuery UI.
I implemented SQL runtime twice, and I'm doing it third time now for vectorized processing.
I joined the Dremel team that became the internal execution engine for BigQuery around mid-2010, just as BigQuery was being announced.
Folks that don't know, Dremel is the query engine that powers BigQuery.
This was a key architectural decision that we made from the start that enabled us to make it easy to use with no tuning knobs.
This enabled huge performance gains for the users.
Okay, we're on. All right. Hopefully that was somewhat interesting. We've got Jingjing and Moshe. Moshe is audio only for the time being. Oh, well, he'll be a picture for us for now, while he gets that sorted out. But yeah, let's get started with kind of talking with Jingjing, who is one of the original papers, the Dremel paper, so to speak, which was what the name of the internal tool that BigQuery was based on came from.
Yes. Hi, Jingjing. Hi, Moshe.
Hey, Felipe.
Hey.
Moshe.
So, I would love to know more about that experience of writing the original Dremel paper. Like, how did that happen?
So it's a good story, right? But we had developed Dremel in 2006, and it, people loved it. We didn't think people would love it as much as they did, but really, we saw this problem, right? That MapReduce was scalable and it was great. It could handle petabytes of data, right? So you could handle all this web data that was growing exponentially. But then you'd write a program. It would take you a day to a week to write, and then it would take you a day to a week to execute, because this thing had to bring up servers, they had to run, they had to pass things back and forth, they had to map and shuffle, then reduce, and we thought there has to be a better way. And so this this fellow named Andrei Gubarev, right? He said, okay, I think there's 3 secret sauces here, right, that we can do to make this thing work really well. Number one, let's get rid of this day to week, latency of writing a program. So we said SQL. Everybody knows SQL. You can write a SQL in like 10 seconds. All right, secret sauce number 1. Secret sauce number 2 is, all right, so, there's all this data, and why are we reading all of it for every question, right? Most of the time there's, thousands of fields, but people actually only care about a small slice. So secret sauce number 2, columnar data. Right? Let's slice this thing up, and if you care about 2 fields out of 1,000, well, let's read those 2 fields, right? Secret sauce number 3 was, having a few hundred node system and organized in this tree structure that's always running, right? Because when you have a question, you don't want to wait 5 minutes for a few hundred machines to come up, right? Instead, you want to ask a question and get it back in a few seconds. And so that was the 3rd secret sauce. And when we discovered, when we built this thing with those secret sauces and served it up, the people loved it, and we said, all right, we want to expose this to the external world, right? So we published the paper, and that inspired Apache Drill, which is kind of like a open source version of Dremel, as well as the columnar format inspired the Parquet's encoding scheme.
It's crazy how there are alternatives to BigQuery around the world. That's good. But it's crazy how much we base on what you started researching here and what Google has been building this whole time. And these are crazy ideas. Like, in fact, that you made the world wait. You said you started this in 2006?
Yep, that's right.
Yes, and the world had to wait 4 years to see BigQuery running for the first time?
Wow.
Yeah, well, the first few years, we weren't sure, right? And there's a bunch of challenges we had to solve. For the first 2 or 3 years, all the data was actually loaded on the machines that were doing the processing. And it actually took a long time for us to get over the fact that, okay, Google's networking is advanced so far that we can actually, separate the compute and storage. And I remember, fights of, us being doubtful, right? Be like, is this possible? Can we really do this? Right? And then in one meeting, Jeff Dean was there, and he says, what are you guys doing? Why don't you guys just keep the data in GFS and then read it, right, without loading all the data onto all the machines? And we were playing tricks with keeping everything on a rack for a single table and all sorts of tricks.
Yeah. Wow. I remember in 2013 when I was showing BigQuery, then people were like, what do you mean data locality? Of course we don't need data locality, we can have things separated. And that's an idea that still blows people's mind.
Yeah, absolutely.
Yeah, you made it simple. Like, we brought SQL to this world, we got the columnar, and just letting people do things really, really fast. And
one of the really cool things about how kind of BigQuery has held up over the years that's been interesting to me is that even though you came up with all of these, like you said, the 3 secret sauces back, call it the aughts, right, the 2006 to 2010 time range, 10 years on, we're not doing things like that differently. And so it's amazing to me that the approach that you uncovered then is still applicable now, even though we have grown multiple orders of magnitude of data that's available in the world that people are trying to process. Compute, of course, has come a long way since then, as has networking, but we're still writing SQL. We're still columnar.
Yeah, no, absolutely. But Moshe can tell you about all the improvements we made, right? It's
yes.
Back then it was, I don't know, compared to what it is now, it seems like a toy, right?
Yes. So let's talk a little bit about Moshe, because Moshe is this amazing person that I was lucky to meet at a Google leadership seminar in the mountains. But since then, I've been learning so much from him and from the work he's done for BigQuery. You have authored 2 papers, Moshe.
Well, only one of them is only one of them is a real paper. Another one is not published in any conference.
Oh yes, it still shows up on Google Scholar and for your other paper.
Yeah, so the interesting one is, of course, about the BigQuery data model and how it handles semi-structured data and nested and repeated fields. And this is something that, I think probably the most revolutionary part and that BigQuery brought to the database industry. Because 10 years ago, the state of the art was, mostly, if you wanted to deal with semi-structured data, probably you may have had XML blobs in your database. That's about it. And moreover, some people just looked at the idea of keeping those complex data models and said, database should not do that because it violates first normal form. Well, here's the thing. First normal form, of course, does not allow multi-values, right, for a single value. However, it says the value can belong to arbitrary complex domain. And that's exactly what we've done. It's also what SQL Standard have done, back in 2003. We said, yes, you can have arrays and you can have structs, and they're not nested tables. They're just natural way for you to model your data, especially for the new wave of internet applications that started in 2000s, like, let's say, Google Search, which actually inspired a lot of Dremel, where, I don't know, you do a single search and you get 20 impressions, 20 links, and then you have multiple clicks, and you also have ads, and many other events. So it could have been modeled, with multiple tables and joins and primary keys and so on. However, writing the application the most natural way is to build this hierarchical thing. Again, this is not a hierarchical model. It is still fully relational. It is still fully SQL Standard compliant. But we did it, from the beginning. It was first-class citizen. We put all the support from the runtime and language and the storage system and all the layers above. And this is the thing which, to me, Dremel and BigQuery, this is the biggest impact to the industry. And that's also the paper that we wrote together with Dan DeLore and Jeff Ullman, whom you may have heard about.
That's crazy. Like the ability to have nested data makes such interesting ways to store everything efficiently. But then you need to break people's conceptions of how the data should be stored. Like I often get Stack Overflow questions on how do I make everything flat?
Yeah.
Like, it won't work.
Well, obviously, if you want to deal with classic schemas, Star and Snowflake or what have you, BigQuery will do that very well too. So, it really depends what your problem is. Sometimes nested data is the best data model, and sometimes, classic star schema is the best model. We'll do all of that, so don't worry.
So yes. So, and your other paper is Capacitor. That's all about how we store data inside BigQuery. That's invisible to users, but you.
Yeah. Capacitor is our storage format, which superseded column.io, which was the first attempt. And as I said, from the beginning, it did support this nested and repeated data model, but capacitor is so much more. So we pushed a lot of runtime operators to work directly on encoded data. But even that is not the most interesting thing. The most interesting thing about capacitor is that it's self-learning format. And we talked a little bit about it in a paper, and unfortunately we cannot talk about all of the things it's doing. But it does things like it reorder rows for the optimal query patterns. It knows how to group columns together. It picks the optimal encodings. Many things. Is probably the thing that I'm most proud of that I've done in BigQuery, my biggest contribution, and it's still under very active development.
Amazing.
That's so cool. Yes. I'm so proud of so many things you've done, especially when you come to the community, because you can find Moshe sometimes actively answering questions on Stack Overflow. You can find him on Reddit, also interacting with people. If you ever wonder who Moshe is in these places, is this Moshe. Like,
right
how amazing is that? Yes.
Yeah.
Should we talk a little bit about ML?
Yes. Let's
and
talk a
what
little
we're doing
bit
there.
about machine learning. That's the hot buzzword these days, right? And now with, I guess it wasn't too long ago, but it wasn't like super recently either. BQML, BigQuery machine learning, became a thing, and Jingjing was super involved in the creation of BQML, and it's really opened up the doors to being able to run stuff straight on top of your data. So I'll hand it over to Jingjing to kind of talk a little bit more about what it was like to build machine learning into a data warehouse versus kind of having those be separated as it has been classically.
Sure. I think that's BigQuery ML is probably, as Moshe said, faster as one of his really proud achievements. I think BigQuery ML would be on my list. Prior to doing BigQuery ML, actually was on the team launching CloudML Engine. And I just remember that was a great project, right? We made things more managed, but still the users had to learn and write TensorFlow.
Yep.
And that was, if you ever had to do that, 2 years ago, it was not easy, right? They had this model, we had to create these tensors and connect them all up, and it wasn't dynamic. You'd have to, run it, kind of connect everything and then start running it. And so similar to, Felipe actually gave me this great analogy yesterday, similar to MapReduce and Dremel, right? I kind of see TensorFlow and BQML having a similar relationship, where instead of, spending a lot of time learning a new language, writing it, executing it on, large-scale infrastructure, why not just type a SQL query and get all the same benefits, right, that you would get in BigQuery, where you can essentially look at some data and start typing and doing ad hoc analysis. Well, now you can do ad hoc, machine learning, training, and evaluation and prediction, right? So
you did it again.
What's that, Felipe?
No, you did it again, Jingjing. Bring everything to SQL to make things simple.
Well, I'm wondering if that's my my life's mission now.
Bring everything to SQL.
Yeah.
Yes. We have this query that we showed people like in our first episode of the data show, before it was called the data show.
That's
so
right.
I don't know if you have it there, Yufeng.
Yeah, I think I do. Whoop, there's our meet window. So we've got the kind of everybody, all the, what is this? Our meetup topics, right? That we were summarizing. And we're running a Kmeans clustering. So a while ago, Felipe and I were messing around and he was showing me the clustering of different topics that different meetup groups were covering, and we made a word cloud out of that, which was super fun, and we used Data Studio to make that happen.
For me, it's just impressive how simple this query is and how powerful it is. Like, we're running Kmeans clustering over strings, and I don't have to one-hot encode anything, normalize, separate testing.
That's right.
What do you think, Jingjing?
Hey, I'm with you, right? I think the Kmeans is a very powerful thing, right? That allows you to identify clusters of things, so you can make sense of the data. These days data is growing in such an exponential manner that really you need help, right? You need more advanced algorithms to help you make sense of it and define patterns, to do predictions, and to get value, right? Our hope is to, enable everyone to make the better decisions, right, using BigQuery. And so, like in this example, if you can look at the group things into, I think you grouped into 6 clusters, right?
Yeah.
Yep.
Because 6 is the number. 6 is something I can think about, right? It fits on, the number of fingers on my hands. Whereas if you have thousands, like I don't know how to think about that, right? What do I do with 1,000 things?
Yeah, and the other thing about Kmeans clustering is like, before this was a reality, there were lots of libraries out there for achieving this, and one of the things that was always tricky in my mind about it was that, yeah, the one line, right? They say is a really nice API for doing Kmeans clustering, great, and it's just like this one line call with a few arguments, but it leaves out all of the stuff around getting your data moved into a format that is suitable for making that one line call. And here it's like we are literally, this is all of it in all together, because you already have your organized data in your tables.
Okay. And it's also crazy how much money, resources you're saving by not moving the data around, having everything taken care of here. There's no exfiltration risk because it's happening right in the database. Like, you really made something beautiful. I would love to talk. I know we could talk about this for an hour. In fact, we did in that show. But I would love to show a little bit another new feature that we announced like a month ago or less, materialized views. And Moshe has done a lot in that regard.
That's right.
Do we have a demo,
Okay.
Moshe?
Yeah, so Yufeng, can you please bring the demo query? Okay, so what we have here is we have a table which has all the flights in US for the last 33 years, which means coming from 1987. And we're looking here at, which flights spend most of the time in air, like, top 5 longest flights. And we're doing it for now only for United Airlines. So can you please run this query?
Yeah, and you'll see that we're
Okay,
running
already
this
here.
with no cached results. So this is the real deal here. And we can
7
see.
gigabytes
Yeah.
of data.
Yes, so it went over 7 gigabytes, less than a second, because everything can be query takes less than a second. Obviously, it's East Coast to Hawaii, no surprises. Now, what if I wanted to get 5 longest flights, but not just for United, for all of the airlines? Obviously, this query will be slow, right? Because, there is more data to scan. Can you please comment out the workflows and run this query again? So it will be slower.
Yeah, because we got to go through all of it, right? All the airlines, not just United Airlines.
Well, actually, it was faster. And instead of going over 7 gigabytes, it went over 560 kilobytes.
Kilobytes.
Okay, so how? Yeah, we removed filter and we scan less data. How is that possible? Okay, well, we know it's possible because of the materialized views. Now, this data set, and you can see it on the left, it has the table, but it also has materialized view. Now, I didn't have to change my query to query against materialized view, right? This is, can you show the definition of materialized view, please?
Yep, let me pull that up. We'll go to details.
Yeah, I'll just talk about it, just scroll. So this is the view, which goes, it picks many different columns as group by, it picks different aggregations, and it doesn't have airline as one of the reporting, as one of the group columns. That's why first query didn't hit it, but it has origin city and destination city, and it has all the metrics that we care about in our query. So, BigQuery can automatically, we could have had multiple materialized views. It automatically picks the right one without you changing your queries. It just works. That's basically how we build BigQuery. Every feature should just work and you should not worry about it.
Wow.
But, even this is not the most interesting thing about materialized views. Okay, fine. Planner can match portions of the plan. It's cool, but not so unique. What is more interesting, if we were to change this table in real life and the data was changing, would still be able to use materialized views because BigQuery is smart enough to detect which data changed and which adjustment it should take. So it would still use materialized view for all the 33 years of historic data, and then fresh data possibly coming through streaming or DML or something else for the remaining one. So, this is just the beginning. For the materialized use, it has some limitations, notably no joins here, but don't worry, those limitations are not for long.
More shades on it. It's still in beta, so don't use this in production.
All right, it's still in beta.
Yeah, but everyone can get a taste of the magic that when it finds out what materialized view to use. You don't need to look at the materialized views, you just need to create them. And then the materialized views are also smart enough to keep up even with streaming data and changes. That's wonderful.
Yeah. I mean,
yes.
that is really amazing. And I just want to emphasize that fact that we didn't have to actually say and then tell the query to use that view. That is worth repeating, because that is, part of the long list of magic that we've now kind of talked about today, just today alone. So,
yeah. Should we move to our next guest?
Yeah.
I love Motion Jing Jing so much, but we have so many cool guests for the celebratory show.
We do. All right.
Thank you, Motion.
Thanks, Jing Jing.
Thank you.
One significant innovation in BigQuery that I'm particularly proud of is BigQuery ML. BigQuery ML enables users to easily train and use machine learning models inside of BigQuery just using SQL.
I led standard SQL effort which unlocked BigQuery's powerful semi-structured nested and repeated data model inside a familiar SQL language.
The biggest innovation that I contributed to is the managed storage system. One of the real advantages of BigQuery is its near limitless managed storage system. We've scaled it to exabytes. We talked to a customer the other day with a 40 petabyte table, and people routinely query tens or even hundreds of trillions of rows at a time. We've made significant investments to make sure it'll also continue to scale well into the future.
Yeah, it was a different meet.
Hello, Michael. Thank you for joining us. It's great to have you on, and we're also, I believe we're going to be expecting Chad to join us shortly as well.
Chad has joined the party.
All right, and I see we're sized a little bit funny here. I'm going to square us up, so folks on the live stream might notice some screen disruption. Yes. Just give it a second here while we...
It's a live show, and it's the first time we do anything as crazy like this.
All right,
it's working.
Everybody's back up together again. Nice. Looking sharp, gentlemen. Thank you for joining us.
I'm super happy to have here Michael Antion and Chad Jennings. Chad is one of, we could call him now the longest serving BigQuery PM of all the BigQuery PMs.
Yeah, it's true.
And I was so happy I met him many years ago. And Michael Antion has brought a lot of the GIS magic to BigQuery. Hi, Mike, or Michael.
Well,
great.
What do you have ready for us today?
Gentlemen?
Is the microphone on?
Is
Chad, Michael?
Yeah, so we wanted to do, so first, thanks for putting the event on. And second, thank you for giving me a peer pressure reason to put on a jacket. And I just going back to an old homage, I just wanted to throw a little bit of love out to the regional BigQuery users. Way to go, Tokyo.
Nice.
Michael and I wanted to come and do a little bit of a demo for you and also launch a couple upgrades to some of the infrastructure that BigQuery has developed around geospatial processing.
Wow,
nice.
More upgrades.
More upgrades,
so
more launches. Love it.
Yeah, exactly. So Yufeng, go back to the query and Michael will walk us through why this is a big deal.
So in that query, we are analyzing lightning strikes in the US, and we find out what county each strike was located in. And that query takes NOAA database of lightning strikes, about 4 million of them, in 2018, and joins them with US counties, about 3,000. And the county is described by complex polygon, and the query finds out what where each location was, and then aggregates by county, trying to find which county is the most affected by lightnings.
So you're doing a geospatial join just by distance.
Yes.
Amazing. I mean, there's
It's
so
actually
many...
not. It's not by the distance metric. It's by whether the
intersection. Sorry.
Yeah, yeah. So like distance, you could actually you could do that join just on an inequality field. But this is actually more special because it's actually geospatial predicate.
Yes, correct. Thank you for the correction.
My pleasure. So we've made a couple upgrades that I wanted to dive into. So when you run a query like this, and so like 4 million lightning strikes, geospatial join on 3,000 counties, as Michael said, it takes like 20 seconds to run. And then if there's a geography in your result set, we actually populate a little Easter egg here.
So in the results set, yeah, in this little drop down, where I'm used to seeing this button, Explore the Data Studio.
We did a full show about Explore with Data Studio. Now it's time to explore with Geo Biz.
That's right.
Yeah. So Geo Biz is a lightweight visualization tool that we developed in conjunction with Google Maps. And the purpose of this tool is, I'm an analyst. I just ran a query. And you can see the result for county geometry there, like the polygon showing numbers of vertices, like that's not intelligible. So let's see this thing on a map. And that's what Geo Biz does. It's not a full GIS suite, but it does show you results on a map and lets you do some styling. And we've got some upgrades to Geo Biz that we wanted to talk about here for the first time.
Let's check it out.
Yeah. So when you click on it, this is what you kind of end up with.
So cool. This is a choropleth of all of the US counties. So for folks who have used GeoViz, you're going to notice a difference right away in that, this is like there are 3,000 counties drawn here, and there are like, millions of vertices. And so GeoViz got a massive capacity upgrade to be able to draw all this. And it shows you, obviously, red is more lightning strikes, and blue and green are lower numbers of ones. So you can see like the thunderstorms that come through, the southeast of the United States here. And so there are a couple other little surprises that we wanted to talk about here as well. But I think we should move on to the next demo to do that.
Sure. Yeah, I just want to point out to people, if people are seeing the lag, it's not on your end. It's that massive upgrade to this visualization. Unfortunately, I didn't get a massive upgrade to my browser to render all of these points. So yeah, this is a much lighter weight set of points, and my mouse moves freely again.
Yeah. So we wanted to highlight some of these items that we've upgraded. So this data set shows the health of trees in New York City. So if you're not a tree person in New York, it might be a bit of an esoteric example, but you notice the limit statement. So we're limiting this to 50,000, right, which kind of restricts things to what southern Brooklyn there. But with the advances that we've made, we can now show this. So Yufeng, go ahead and give us the next tab, please.
Yeah. So this has no more limit. The limit does not exist.
Yeah. We've taken the limit away, and so now instead of like just 50,000 points that we were showing before, we've got 650,000. So now we're just limited by the RAM on your computer, so we can do a lot more. But I also wanted to point, so that's one, we blew away the limit. So kudos to the engineering team for doing that. I wanted to also show off a little bit of the, call it the magic wand here. So Yufeng, if you could select the data or the styling here and show the effect of the magic wand.
Yeah, let's go to the data step here. And down here, there's this little fun little button.
Add styles.
And I'll click Add Styles. Yep. And that'll bring us to the next bit. And you'll see there's nothing here. And that's why this map looks terrible. And we can apply.
Exactly.
Or I guess I have to click the wand again.
So if you click on the wand, what it does is it just institutes some defaults. So you can, there's a default query, there's tree one, default styling, and if you click on the wand, it'll apply those defaults. So that, you know, basically just helps with the onboarding. And if you click on apply style,
yeah, no, we're green.
Voila. Yeah,
that's how magic it is.
Yep. And so the last thing we wanted to show off on the left-hand pane is that we've also added a share option. And so you can now share this map with the styling with anybody who has access to the underlying project.
So you're respecting the data permissions while you are sharing the whole display and settings. That's awesome.
Exactly. So you inherit all the IAM permissions that come along with the project. So you're not leaking any information here. So that was the last, like in terms of the upgrades, that's what we wanted to walk through. And then Yufeng, did you find us a tree?
Did I find? So let's see.
Just because we're running a little short on time, I really want to thank. I love how Matt, Chad, and Michael care about users. Like Chad has been a big sponsor of us having the free BigQuery tier where anyone can come and try these things without a credit card. I love also the project that he's leading on how we help the world, especially in the current crisis. And I also find so amazing how to interact with Michael on Stack Overflow. He keeps a Medium blog where he writes a lot of tips on how to make the GIS queries better. And whenever I have questions about it, he's ready always to help make everyone's experience better.
Yeah, let me say just a word or two then, and then I'll give the mic back to the hosts. You know, as BigQuery grows, and you know, Jordan did a great job of talking about it. Like we're being adopted by larger and larger enterprises, which is awesome, right? They push us in good ways, and we produce more features that are awesome, like hourly partitions, etc. But you know, BigQuery and Google comes from like the John or Jane Doe developer community, and so we can't forget them. So we have to make sure that our features also support like the long tail of users or folks who just want to come and try it. So we have the BigQuery Sandbox, which is a no credit card, less than 1 minute onboarding flow. We'll add the links to the comment section or to some of the follow-up material so everyone can have a look. And that way, folks can come and just click into the sandbox and go ahead and use the product. Geo Biz is a free product. Data Studio is also a free product. Data Studio just launched support of Google Maps. We'll add the link there. So we really want.
We had a full show about it.
That's right.
Oh, that's right. We really want to take care of our enterprise customers because they're super important to the business, and we want to take care of our developer community because they're super important to our culture.
I have to say thank you. I would love to geek out about maps with both of you for an hour, maybe in a future show. But let's get to the last part of today's show because we still have a lot of content.
That's right.
Thanks for having us on.
All right.
Thank you.
See you soon.
When we launched the first version of BigQuery, we launched Dremel more or less as is. But as usage grew, we realized that we needed a deeper collaboration with the team that built it.
In 2014, the Dremel team and the BigQuery team were brought together by the mandate of our senior vice president, who said that there would only be one set of infrastructure tools, not a separate set for internal and external users.
These days, those teams have merged, and we're now one single team dedicated to bringing the best of Google's data analysis expertise to the world.
This was a revolutionary moment in Google's cloud computing when I think we really became serious about serving external users and making their experience as good as internal users. It's really been inspiring to be part of that.
We've seen customers be able to reduce the amount of time and effort it takes to create a machine learning model from months to days.
So for several years, I was responsible for getting internal users, Googlers, to migrate onto Dremel. And as part of that, I would track and report a metric about what percentage of Googlers were using Dremel. At that time, we got to 85% of Googlers were using it on a monthly basis and 75% on a weekly basis. And that's not just tech Googlers, that's all Googlers across sales, executive leadership. And I think that sort of democratization of data is really the benefit that a tool like BigQuery brings to organizations.
Let's be quiet. Here we go. And we're back. So now we have Jordan on again, and we're joined by an extra guest. Felipe, you want to introduce her?
Oh, Michelle Goodstein. I love her. Like 2 years ago, I sent an email to the team. Hey, I need to read these Parquet files. How can I read them with BigQuery? And everyone pointed me to Michelle, who you had just joined the team at that time, and you were looking into how to expand BigQuery beyond the managed storage.
I think I've been on the team for about 5 months, so.
You consider as a noogler 5 months. Is that transition period?
There's a lot of ramp up. That still counts as a noogler. Yeah, exactly.
Yes. It was so awesome to meet her and to see like from her start and to like how do we launch these features. You presented this feature at Next Japan Tokyo last year.
Yes, it was really fun.
Yes. And I love that you use the files that I had the problems with.
Yeah, exactly. This was that common crawl data set, which is that open data set of web crawl data, and we have about 3.5 terabytes of it there stored in high partition Parquet on Google Cloud Storage.
Exactly. So usually we want to use BigQuery's managed storage and put everything in BigQuery, but this is opening up our options.
Right.
Exactly. So now you get the ability to query columnar storage. So this launch included both Parquet and ORC, so 2 columnar open source formats that we can now query, leaving the data on Google Cloud Storage. And also the ability to have that data partitioned, which really gives you power to have really large tables, but only query a subsection of it and not have to read all the data.
And this is a query that Yufeng can run it now. In fact, you run it, Yufeng?
Yeah, so we've got this data set, and this is actually the common crawl data that they were talking about. And we'll click run. This is going to query an external table. That's just Parquet files loaded on cloud storage, if my understanding is correct.
Exactly. It is that data set that Felipe and I first started talking about on an email chain almost 2 years ago. And what it's doing is make the crawl and subset fields on this table are actually high partition keys. And so it's saying, let's count the number of times Google appears as a top level domain in a very specific crawl, and it's breaking it down by the URL host name.
Nice. So the query is complete. I'll hide the editor so we can take a look at the results. Yeah. There you go.
Yeah.
So something that I find fascinating, Michelle, is like just the process of thinking, would I be able to join the BigQuery team and become a BigQuery engineer making this magic? How was that for you?
You know, it was really fun. There's definitely a ramp that may, like, you don't start with a bug, you start with a project. So like to me it was like make the way BigQuery reads JSON faster, whether it's a query or loads. And so I worked on that for a couple months, and then it was like, okay, there's this project that's ramping up. We're going to be querying Parquet and ORC, and we want to be able to handle this externally partitioned data. And so I just jumped in, and I got to see the entire evolution of the process. Got this opportunity to go to Next Tokyo and present, which was amazing, and it's been fantastic. And Jordan's the one who hired me.
Yeah, that's fascinating. how the circle is complete here.
It took a couple of months to convince her to join the team, but I'm so glad that it worked out. And it was a hard project. It was hard. The adding additional data formats sounds relatively straightforward, but all the security requirements and just sort of making all the weird edge cases work and making it seamless is really tricky. And then making it fast, because nobody wants it if it's going to be slow. And this is used for many petabytes of data per day and trending sharply upward.
Wow.
So we're almost on time, but I think we cannot leave without talking about this last feature. That it's such a great feature, and I can explain why in a second. Would you like to talk about it a little bit, Jordan?
Sure. So we're launching today. Our other feature today is dynamic SQL. And so it's what if you put SQL in your SQL so your SQL statements could write SQL? It's the ability to, in a SQL statement, you can write additional SQL. You can say, I want to execute this SQL statement, and in the context of a script, you can build up a string, and then you can decide what you want to do. So really, kind of making if your goal is Skynet, and to make BigQuery can becoming self-aware pretty soon. You just need to come up with the right query.
Do you have Lux blog post, you think?
I don't have it on hand.
I think, it's on the chat window if you need the URL. But if you don't have it there, we can talk about it.
I'm very fast at typing, so I will type it manually while you talk about it.
Slack. Yeah. Laxmanok. Laxmanok, yes. I love Lux so much. He also joined the team, I wanted to say recently, but now it's several years, and it's amazing how much he's done, including writing the BigQuery book, the latest BigQuery book with Jordan. And if anyone wants a BigQuery book, it's right now, and it's a very nice offer with Humble Bundle.
This live stream brought to you by...
Amazing. He gets on top of this from the day that it launches. He already has the blog post ready to go, and knows the feature better than almost anybody.
Yes, he's really, really great. And also being able to read his blog post, share with him, travel with him everywhere has been amazing. And if you jump maybe to the last query, which is the most impressive one in this post.
I'm trying to find the one where the queries are, wow, there's a long query. That's a big query.
Yeah. So again, we could spend an hour talking about this, but look at how cool it is that he's able to look at the information schema. He's able to find the columns out of the query, and then build a query inside the query that will go through whatever columns he discovered.
Yeah, so that's
I know where you're going with this, Felipe. I think I know where you're going with this. Is this the thing you've been trying to solve for 8 years now, 9 years?
Yeah. Since the day we announced BigQuery, I remember 10 years ago. Well, I don't remember, but you can go find this email thread where people were like, "Oh, this is crazy!" And the first question that people ask is, "Can you pivot?" And every other week on Stack Overflow, we get that question: "How can I pivot in SQL?" And for 10 years, we have not been able to give a pure SQL answer. Now we can. This is the answer. We can pivot. You can rewrite queries and define dynamic columns inside. And
amazing.
I think...
Finally, 10 years it only took us.
Yes.
Yeah.
So what would be better than to close here with Jordan, Michelle, and thank everyone that has been here. But I don't know if you want to say final words for this amazing show we had today.
Yeah, just thanks for including me. Thanks for everybody for tuning in and for being, for supporting BigQuery. We're going to have a lot more exciting things coming up. Our roadmap, our near-term roadmap has some amazing things, and then our 10-year roadmap is going to be even more interesting. Most of those things, we don't even have any idea, and hopefully our customers and our users and our community are gonna help us get there.
Amazing. Thank you so much, and thank you everyone who joined us and the community. To close us out, we have one final clip that we have thanking folks about BigQuery, and so with that we'll sign off, and we'll see you next time on the Data Show. Thank you so much to everybody. And we'll see you soon.
Thank you.
I'm proud to have been able to contribute to bring the best of Google's engineering expertise to the world.
I draw inspiration from learning how BigQuery help people, whether it's to run their businesses or to help social causes like fighting illegal fishing, tracking air quality, or more recently helping research against COVID-19. So big thank you to our BigQuery users.
You've been critical to our success so far, and with your help, I think the next 10 years will be as exciting as the last.